Morning, guys. Good morning. How are you doing today? So today we are going to today we are going to talk about the load balancing concepts. And we will see what exactly is a load balancer, how does it work. All those things we are going to see today. Let me share my screen and then we are going to start. Now, load balancers in AWS. Now, from the name suggested, what is load balancer is? What is a load balancer? Okay. So when I say a load balancer, basically a load balancer in AWS is a service provided by elastic load balancing which is ELB, okay, that helps to distribute incoming traffic incoming network traffic across multiple targets such as EC2 machines or instances or servers, IP addresses, okay, in multiple availability zone, but same region. It's a regional service. Okay. So the goal of load balancer, the goal of load balancer is to enhance the availability. Enhance the availability, fault tolerance, and scalability of applications. Now, what does it mean? Say you have a machine. Okay, I will also teach you auto scaling, but yeah, for now, I'm talking about load balancer. So let's say you have two machines. This is machine one. This is machine two. Okay, both are running the same application. Now, traffic is come to these applications. Okay, so let's say you're using Route 53 and you have defined the A record and you have given the IP address of both the machines, and then what will happen is it will send some traffic here, it will send some random traffic here. And what is happening is 95% traffic is coming here, which is, and this machine is running at 90% capacity, and only 5% capacity traffic is coming here. And this machine is running at 5% capacity. Now the problem is there would be like people who are 90% of the people will experience a lag. 90% people will experience the lag, and there is no lag in this, but this machine is unutilized. Machine is unutilized. And 90% of the people will be not having the best of the experiences. And only 5%, like it could be vice versa also. Anything can happen here. The traffic distribution need to be done in a proper way. If I explain you with a simple example, let's say there is a manager in the company. Okay. For under this manager, there is two workers working. I have Akshat working. I have John working. Okay. Just a minute. Yeah, just a minute. I'm just messaging you only. Okay. Yeah. Now, here, the manager will be like it have two people working, Akshat and John. And what manager is doing, let's say there is a every day there is a 16 hours of task is there. So manager is giving 14 hours task to Akshat and 2 hours task to John. So total 16 hours of task was being done, was being distributed between both of them. But the problem is Akshat is overutilized. Akshat is overutilized. Akshat is overutilized and John is underutilized. And ultimately, Akshat will leave the company and John have to do 16 hours of work and John will then leave the company. The complete setup is destroyed because of managers' stupid nature or managers' behavior here. So what we have done, we should do, or what manager should have done is should have distributed the load equally between John and Akshat so that they are able to work in a proper way. So 8 hours he can do here and 8 hours he can distribute it to John. So that total 16 hours task can be distributed rather than just giving complete task to one or not distributing it in a proper way. Same thing happens here also when traffic is coming. I need to equally distribute the traffic between the infrastructure, between the machines, let's say. so that like both the machines are working in a proper way. And later on, if I want to increase the number of machines automatically also, I should have that understanding that, okay, in what scenarios it should increase a new machine. If all the machines are receiving different traffic, what scenario I will be able to make here. But if machines will receive equal amount of traffic, okay, then I can make a scenario that if machines average CPU utilization is more than a particular value, then a new machine should be created up automatically. That is auto scaling. So a load balancer is very important. So I should put a load balancer in between. I should put a load balancer in between, wherein it will equally distribute the traffic for you. So we will have 50% of traffic coming here, traffic coming here. So equally distributing the traffic. Okay. So a load balancer in AWS is a service which is provided by ELB, Elastic Load Balancing, that helps to distribute. It will distribute the incoming traffic which is coming up across multiple targets. We have multiple targets such as EC2 machine in multiple availability zone. This machine could be in availability zone 1 of, let's say, region Mumbai. This could be in different availability zone, AZ1B of region Mumbai. So it should be the same region. It cannot be in two different regions. So of the same region. The goal is to enhance the availability. Okay, my if one machine has the all the load, then my machine can definitely go down. So it will ensure that the availability is more. It will also do a health checks. It comes with a fault tolerance in case of some issue comes up in any of the machine. Since it is doing health checks. So load balancer, I will write it also separately. Load balancer will do health checks. So if some issue comes up in any of the machine, it will stop sending the traffic. So fault tolerance, scalability, ultimately. So yes, load balancer is a very, very important thing we should know about. And these are some of the some of the important points about the load balancer. Take a note of it. Okay, done. Now, now when I talk about the types of load balancer, okay. So majorly we have four types of load balancer, of which one is discontinued now. Okay. So earlier, like we used to have four types. Classic is discontinued in on 15th August 2022. Okay, but I will write all of them. Okay. So we have application load balancer. Okay. We have a network load balancer. We have a classic load balancer which was discontinued. Old load balancer which are using classic is running up. So those, let's say some project was running before 2022 and they are using classic, it's still running, but it was discontinued for new user. Okay. Then we have gateway load balancer. So we have like four types of major load balancers. Okay. I can say this is being used in like around 30-35% of the market right now. Okay. This is being used around 40 to 50% of the market. Still, the people are 5 to 10% of the market is using it, and 3 to 5% of the market are using gateway load balancers. Like it could be different. Okay. This is from my experience. I'm telling you, like majorly I work on an application or a network load balancers only. So yes, we have multiple types of load balancers, which is there. We are going to discuss each one of them one by one today. So let's talk about the application load balancer. The application load balancer is there. No, Deepak, nowadays it's not required. Some old architectures, they were using it, but now it's not required. Now, when we have the application load balancer, it works on the layer 7. It works on layer 7 of OSI model. Now, what is an OSI model is? So, okay, what is an OSI model is? See, OSI model, the full form of this OSI model is basically Open System Interconnection Network. It is a networking concept. Those who have done a CCNA course or those who have done those who are from computer background, okay, CSC background, they might be aware of the OSI model. It's being taught in the college in the second year itself. So it's one of the conceptual framework that standardize the function of networking into 7 layers. And it basically helps the different network devices to communicate with each other regardless of manufacturer or the software differences. Each layer, if you see physical layer is there, it will transmit the. So we start from here. You send a mail to other person. So it will be on the application layer, which is a human computer interaction layer. Okay, where the application can access the network services. So this is the layer where the application will be accessing the network services. Then we have the presentation layer. Presentation layer will ensure that data is in the usable format. So the next layer it will go is on the um, this thing. Sorry, to the presentation layer. Okay. Now presentation layer translates basically it translates the data between application layer and the network. It will handle your data encryption, decryption, compression. You don't, okay, and other things. You don't have to really worry about it. No one will ask you. I'm just telling you so that you have an understanding about it. Then it's a session layer. Okay. So session layer, it manages the sessions or connection between the application. Okay. So let's say I want to transmit it to another system. So it will go from here and then it will go to another physical layer, data link layer, network layer, transport layer, session layer, presentation, application, and finally reach to the destination. If I'm sending a mail, suppose I will send from here, it will go to this process and then go to here. In session layer, it manages, it sets the connection with another system, the destination. whether that destination should exist or not. So what does it do? It manages the session. Okay, it manages the session between the application. Okay, so it will take care of sessions. Okay, termination of the sessions, maintaining the session, all those things it will take care of. Then we have the next one, which is transport layer. It ensures, okay, it ensures the reliable data transfer between the system. It manages the segmentation of the data, flow control, and error checking. The transport layer also handles the retransmission if it requires. So it will, it in like basically it will, this transport layer will ensure that reliable data transfer is there. So what it does, it basically breaks the data into small chunks. Here, what happens is it breaks the data in small chunks. Data in small chunks. Okay. And it also it will also regulate the data flow to prevent network congestions. It ensures that data arrives without the error. So all those things this network layer will do. Then we have the network layer. Network layer, it handles the logical addressing and determine the best physical path. It will decide which physical path the data will take, where exactly or what exactly the data will, what path or what is the best path for data packets to reach through the destination. That is being taken care by it. Data link layer. It manages the communication between devices on the same network. So it will provide some error detection, error connection, and the flow control. So it manages the communication. It will manage the communication between devices on the same network. Okay. And on the first layer is a physical layer. It handles the physical connection between the devices. It is responsible for transmitting the raw binary bits over physical medium like cables if it is connected via cables. So it will ensure that the connection is being like it is able to transmit that data to other layer. So we don't have to really worry about it, but we are going to talk about this part here. But personally, you don't need it. Okay, you just have to remember no one will ask you in really in depth. So when I say about types of load balancer, first is application load balancer, which is also known as ALB. Okay. It works at a layer 7 of the OSI model. So what is this layer? What does it work? It works on layer 7 of OSI model, which is the application layer. Okay, it is idle for HTTP, TPS traffic. It is idle for HTTP and HTTPS traffic. Okay. It is okay. Now, it is basically majorly used or it is best for modern applications including microservices and container based. Nowadays we use DevOps only, so we use majorly application. That's the reason I gave the most to application, but it depends on person to person. My major task was in network load balancer, so it depends on person. But these days, a lot of companies are being using the application load balancer, but it is used for modern application, including microservices and container based, which is including this architectures. Okay, so now, okay, so it has majorly Roshan. It has a feature called as request routing. I'm aware of two features which it has. Like it has a path based routing and host based routing. So the application load balancer has, or I can say, offers advanced routing features such as path based routing and host based routing. If this is if this you're talking about this request routing, no, if it is newly available, I need to cross check that once. Okay, so it's a path based routing and a host based routing. Now, what is a path based? From the name, what do you think? What is a path based routing and host based routing? What do you think by what with the word how host based and the path based routing? Okay. So in the path based routing, what happens is, okay, in the path based routing, it allows the traffic to be routed based on URL path in HTTP request. Okay. It means that load balancer inspect the part of URL after domain name. Okay. And forwards the request to the load balancer. There's a target group in the load balancer. Okay. Then it will forward it. So let's say if a client requests a specific path, the the this ALB, which is application load balancer, it will forward the request to appropriate target that, okay, this is where this particular traffic should go based on the URL path. So let's say if you want to open images, okay, on one of the set of servers, or you want to send a traffic for images to one set of servers and traffic for API to another set of servers, to products to another set of servers, it can be done via path-based routing, via the path-based routing. Whereas the host-based routing is there. Okay. Host-based routing allows decision to be made based on host header or the domain name. So allows decision based on domain name in HTTP request. So the load balancer inspects the requested domain name and forward the request to different target groups based on the host name. So let's say if you're working on some subdomains, let's say you have product.flipkart.com or any website. If there's a website, there's a lot of subdomains. Product.akshar.com. You have blog.akshay.com. So in such cases, okay, so the request coming to this, let's say product.akshay.com, okay, can go to one set of servers, while the request which is coming to blog.akshay.com can go to another set of servers. I will explain you, but can you just take a note of it? Okay. Now, what exactly happens in this case? What exactly happens is, see, traffic is received. So we have an application load balancer. We have, let's say, some microservices, or let's say some, here we have the product page is running here. We have the accounts page is running here. Our accounts complete for services running here. We have, let's say, home page is running here. Okay. So in this load balancer, we have listeners, which will listen to the traffic. Yes, this is an application page. This is a EC2 machine on which different parts of applications are being running now. Okay, it's being configured, different pages of the application, and this is a load balancer. Here we have the listeners, which will listen to the traffic. Here we have listeners. Listeners will listen. It will listen to the traffic. We have transmitters, which will transmit the traffic or transmit the request. It will transmit the request to EC2. Okay. So what happens is, we have the traffic received on the application load balancer. We have a traffic which is being received. Traffic is received on the application load balancer. Let's say someone wants to open the product page. Someone wants to open the product page. So the request will come up here. There will be some processing which happens, which will we can say a path-based URL. It will check what is basically the path which is, or which machine this is being hosted. And then it will take it to the proper machine. Okay. Second thing is, let's say, if you are working or someone opens accounts page. So it will go process, and then it goes to the EC2 machine. Then if someone opens, let's say, home page, the listeners will listen to the traffic. So let's say someone wants to open the home page. It goes here, it comes back, and it transmits to the home page. So we are transmitting the traffic in a proper way, just to ensure that Okay, just to ensure that the traffic which is received by EC2 should be proper, or it should not be received to any other machine. Why we are doing it? We can actually send, they are on the same network only, these machines. We can send it to any machine, and from that also it can transmit it very easily. Okay. I do not get it yet. Do load balancer balances between the similar traffic? See, it is a, see, it could, it's the same application. It's the same application. These are the functionalities within the same application. Let's say, let's remove it. Okay. I will start. Let's remove this part. Okay. Let's say I have an application running up. I was just explaining application load balancer. Load balancer, I have already explained it to you. I was just talking about the application load balancer. It's the same application which is there. Some request comes up to the application. It will balance the load between all the three machines. Okay, that is what a load balancer is doing. A load balancer balances the load. Load balancer balances the load between machines having the same application. Having same application. But let's say your application is very big. Your application is very big. Okay. You have, let's say, your application has a product page. It's a e-commerce, like this Flipkart, like a Flipkart. Okay. This is an e-commerce application. It's one of the biggest in India. Okay. So we have, this is a product page. This is a sign up page. This is the accounts page. Now, the traffic is received. Okay, traffic comes up. I want to open the product page. I want to open the product page. When I open this product page, okay, someone comes with a request from the internet. Someone comes with a request. Let's say akshar.com is a website. I want to open the product page. Let's say that example. So it will use a path-based URL wherein the request will come up here. It will be processed within the application load balancer, and the request will be transmitted to the application which the machine in which the product page of this application is running now. Application is same only, akshar.com. Similarly, someone wants to open the sign up page. So person opens akshar.com, said sign up. So request will come up here. It will go to the path-based URL, and then it will go to this page, this path. So sign up page will open for me. Someone wants to open accounts page. So akshar.com accounts. Request will come up here. It will go to the path-based URL, and it will be routed to this EC2 machine where the accounts page is opened up. So what it is doing? We are sending, like, if there is two machines, okay, a lot of traffic is coming on the product. I have two machines with product page. It's fine. It's the same application also only, no? So it, whenever it comes up, it will, some request will come up here, some request will come up here. Overall, it will balance the load in overall application. But within that application, the functionalities, I can balance the load between those functionalities also with the help of application. Like when I will be using application load balancer, when you have lot of functionalities, lot of machines are there. And when it's a lot of machines, I cannot just randomly send traffic anywhere, just like that. I need to go for the, like, I should be using the application load balancer, which will balances, like I'm telling you the real time use case. Okay, so in application, ALB is used when you have a lot, okay, a lot of pages, functionalities in your application. Like if you talk about example e-commerce, you have so many pages. Okay, or you can take up any website. Yes or no? Are you able to understand it? Yes or no? Please give me a quick confirmation. Everyone got it? Please confirm. Okay, please take a note of it. Now, whenever you have lot of functionalities, lot of microservices, lot of containers, if you're talking about DevOps, in those cases, we can go for the application load balancer and it can be changed also. It's not like I should be sticking to the application load balancer throughout my life. I can change it. If I feel that no, application load balancer is not suitable for me, the solution keeps changing. See, if you are not changing the solution, you will lose your job. That's very simple. You have to be very smart. You have to ensure that your dependency is always there in the company. And I'm telling you this thing. You have to ensure that things are left out in for the end. So that at the end of the day, there is again requirement comes up and you have to be engaged. If you make a 100% robust system in the one day, then they will not ask you again. And you have to again look for another project in your company. So it keeps enhancing. They will keep asking, yeah, this is no, I want to reduce this thing. I want to add up this thing. You should understand it. You should understand the significance of it. And it can be easily integrated. Your different teams integrated. You just need to design the solution. You need to understand this concept. That's it. Okay. You understood, right? What exactly is doing we are doing up here. You didn't got me properly? Okay. I will repeat it, no problem. Which part you have not understood, or can you please tell me? I will repeat that part here. Oh, no, this you have understood. Yes, okay. That I was just saying that let's suppose you have a requirement coming up to you. Okay. Let's say, or you have to design a solution for an e-commerce company. Okay. You have to design some solutions for an e-commerce company and they are expected to receive around 1 million requests a month. Okay. They are very much concerned about the security. They are also concerned about ensuring that the traffic is being distributed in a proper way. Okay. Now, Aurak, you're very smart. You can easily design such a solution. It's also available on internet. It's not something which is very unique. So, but what I was saying is we sometimes don't take it otherwise, but sometimes we do not just directly create the best design. We just do not create a best solution. If you're working in IT companies, you just have to put some scope for rework later on. So that later on companies will again come up that, okay, we are not getting this much of efficiency, please rework on that. So that your engagement should always be there. Otherwise, if you will create it, then they will say, okay, our solution is now perfect. You can search for other projects in your company. We don't want it. And this happens. If you are not engaged in DevOps, in solution architect, this can happen. But companies are never satisfied. The clients are never satisfied. They will keep asking to create some enterprise solutions for them on a daily basis. Like, okay, how I can improvise this thing? Do you have any suggestions to make these changes? So that is definitely there. Okay. Now got it? I was just talking. Okay, it's not something related to the topic. Now, when I talk about one of the very important feature, which is health checks, it is being present in all the load balancers, but health checks in application load balancer is there. So what does a ALB does? ALB performs health checks on its registered targets, which is EC2 instances, containers, etc. Okay, to ensure that they are healthy and can receive traffic. Okay, it automatically routes the traffic away from unhealthy instances. It automatically routes traffic away from unhealthy instances, machines. Okay, so it does check if my applications are healthy or not, and if my EC2s are healthy or not. If it is not healthy, then it will stop sending the traffic to that specific EC2 machine, and that's a very, very important feature. Automatically does it. So it does a health check. So this is a load balancer. It does a health check. If this machine is unhealthy and this machine is healthy, then what it will do, it will stop sending the traffic to this machine. Traffic to this machine. Okay. And it will keep sending the traffic here. And later on, my auto scaling will create a new machine. That also I will show you. Okay. You understood till this point? Please confirm. Now we have the second one, which is a this network load balancer. Okay. The second one is the network load balancer, which is there. In the case health check, suppose the product page is not working. We always have a auto scaling also enabled. So if health page is not working, let's say the machine is not working, okay, it will redirect it to another machine, which is where the health check is being, the product page is being running up. Okay, if it is not present up, it will redirect to another. It will redirect it to another page itself. That is also, it will just, let's say, it will not open it, right? Will it launch after unhealthy instance? Will it launch? Yes. Auto scaling is something which we can also integrate within the system, and auto scaling will ensure that if a load balance or if a machine is unhealthy, a new machine should be created. So auto scaling will work on that particular behalf, Rahul. Elastic load balancers check 200 code. Yes, it will be checking the 200 code itself. Yes, absolutely, Gopal. Okay. Any other question, guys? Now the next one is a network load balancer. A network load balancer, it operates on layer 7. Operates at layer 4, which is a transport layer. Okay, it operates on the Network it operates on layer 4 only, no? Network load balancer works on layer 4, not on layer 3. I will check if I'm by chance I'm. Yeah, it works on the layer 4, fourth layer of the open. Okay, see. Network load balancer works on the fourth layer of the open system OSI model. Okay, see it's there mentioned. Now, if you are saying something, I have to check it out because it's not like you guys, you have that understanding. So I've cross-checked it once so that your word is also being taken care of. So it operates as at layer 4. Okay. So what happens in the network load balancer is the network load balancer is basically it is designed for the application that requires, it is designed for applications that requires, okay, that requires extreme performance and low latency. Extreme and low latency. Okay. It is designed for the application that requires extreme, the best performance and the lowest latency. So the application which has, let's say, Netflix application, if I say, in Netflix, you are using NLBs, network load balancer. Absolutely, NLBs was being used there. Anyone who's working for Netflix here? Anyone? Like, I left Netflix around 7, 8 years before. So that time we were using NLBs. If anyone is working right now, they will give a better picture. But that time we were actually using the network load balancers only. Okay. So it was designed. Now, Netflix used to receive millions of requests, which is there. Okay. And if I want to handle that million of requests which is coming up, okay, then I should be going with the network load balancer. But in network load balancer, there should be less microservices or there should be less number of machines running up. That's where the network load balancer is successful. Let's say if your application is dynamic, so there is less functionalities altogether, but more traffic. Let's say Netflix, everything is dynamic content. The number of pages are really less, but everything is dynamic. In those cases, network load balancer is successful. But in case of the e-commerce, I will have a product page. I should have an accounts page. I should have so hundreds of pages. I need them. That I cannot make it them dynamic. The content can be dynamic, but I need those pages, which is not in the case of Netflix. If you open any web series, that's a dynamic content. The actually pages does not exist. There is only one page, movies. And under that, all the things which is coming up is dynamic. So here also, in such cases, when millions of requests are being coming up, or like when there is you need a best performance and you have a really huge number of traffic which is coming up, then it's a network load balancer. I can take an example is OTT platforms. OTT platforms like Hotstar, like Disney Hotstar, Disney Hotstar, Prime, Amazon Prime, Netflix. They are using the, okay, okay, GD1 application load. Below network load balancer, there should be one application load balancer, right? Or else how the traffic will go on the application and networks. Yes, in this case, what happens is within the machines, the traffic will go. Let's say if all the machines are running on the same network, so it will go to any specific machine, and from that machine, it will be pointed to the correct location. So you don't have to use the application load balancer with the network load balancer. There is no point, right? As such. Okay. So it handles TCP, TLS, and UDP traffic. UDP traffic, which is there on the layer 4 of the USI model. Okay. And it is capable of handling millions of requests per second. So if you are receiving millions of requests, okay, and you have less number of machines, let's say this, you have 3 machines, let's say. So, and you're receiving millions of traffic, then you will go for the network load balancer, where we have the listeners, we have the transmitters, traffic will receive to the listeners. Here, there will be there is no process which is happening up. It will redirect it to any machine. From that machine, if there is in another location, since it's a dynamic content, it does not matter. But yeah, if let's say that particular page is running here, it will point from here, it will go to that machine. But if there are hundreds of such machines, it's very difficult. That's the reason why we use application load balancer. But here, if the machines are less, okay, but you are receiving millions of requests, million of traffic you are receiving, then you should be using a network load balancer. And I gave an example. There, e-commerce, majorly if you're working on some e-commerce platforms where there is a lot of functionality, a lot of microservices, functionalities need to be developed. There, you will be going with the application load balancer. You can change it. If you later on realize that this network load balancer is not suitable for it, you can change to application. But you should have that understanding as well. It's not like, okay, I've fixed it up, I cannot make the changes. That will happen on a daily basis. But when I should personally be using a network load balancer, when I have less functionality, like less number of functionalities, less number of machines altogether, and millions of requests which is there. In that case, I will be going for the network load balancer. If I say unique functionalities, it should be less and more number of traffic. It can increase, the machines can increase with the auto scaling, but they will have the same applications running. So if let's say app is running here, and a particular page is running, here also the app and page 1, here also the app and page 1, everything will be in that same pattern itself. Understanding, yes or no? Please confirm. This is little confusing. I think it was done by previous trainer also for you. I think all these things was done, right? Yes. Okay, great. If the number of requests is more than NLB, and if the type of request, then ALB. Yes. If then more the number of requests, less functionalities, less number of machines, then you can go for the network load balancer. If you have more functionalities, more number of machines, initial machines, and you have normal traffic, then you can go for the ALBs. Okay. Any other question, guys? Got it? Please confirm. Okay. Now the third thing is the gateway load balancer. gateway load balancer. You will not get any questions in even professional level certificate from what I'm teaching right now. Not even a single question. Not even a single thing. Okay. So gateway load balancer is basically, it's a type of load balancer that is being designed specifically to distribute the traffic across a fleet of third-party virtual appliances. So it's one of the type of load balancer which is not used much. This is a load balancer in AWS. Okay, that is designed specifically to distribute the traffic across a fleet of third party virtual appliances. Okay, third party virtual appliances and that are used for tasks like firewalling, intrusion detection, okay, prevention system, deep packet inspection, which is DPI, and other network security tasks. Okay. It simplifies deploying, scaling, and managing these virtual appliances by providing network balancing between them. Okay, a gateway load balancer operates basically at layer 3. It operates on layer 3 of OSI model. Okay, which is the network layer of the OSI model. It is used to distribute the traffic to virtual appliances that are performing some security functions. Okay, so what it does, it balances the load. It's used to distribute viewed traffic to virtual appliances that are performing security functions or other tasks requiring inline packet processing. Just take a note of it, then I will explain you. Done. Now, what happens in the case of gateway load balancer is, let's say I have a load balancer. Sometimes all these machines know, let's say I have an application running up here. So sometimes we use some third party virtual appliance, let's say for security measures like Geneva. Okay. Now, what I need to do is I need to distribute the load. Okay. I need to distribute the load across a fleet, like there could be a fleet of virtual appliances. So traffic is coming up here. It should go and then the traffic distribution should happen. So this virtual appliance need to be configured with your load balancer. Okay. So what does it, what in those cases we can use the gateway load balancer. Gateway load balancer. Okay. In such cases, we can use a gateway load balancer. So what does it do? It basically, it combines a transparent network integration with load balancing so that you can easily deploy and scale these applications. Okay. So, okay. So in this cases, I can say in such situation, that is really not very correct definition, but yeah. In such situations, when you are using some third party virtual appliances or you are using like firewall, some IDS, IPS. So the traffic will first redirect to the gateway load balancer. This is a gateway load balancer, GWLB, gateway load balancer. And then it balances the traffic across the group of virtual appliances. And that virtual appliances, okay, then that virtual appliances might be connected to some machines. Or if there is a group of virtual appliances, it will balances the load between those virtual appliances as well. And then from virtual appliances, let's say if it is establishing one-to-one connection, it can be established. That is also being possible. And this is majorly which is used. Okay. What is a virtual? Just think of it as a firewall. You have purchased an external firewall. External firewall, which adds up an extra security on the traffic received on your machine. Okay, that is what we are calling something which you're configuring separately. You took it from the marketplace, you purchase it, it comes with like thousands of dollars, and you configure it. Now all the traffic will go to this firewall. We have security group and other firewalls which is there, but there is an external firewall which you have purchased from the marketplace, AWS marketplace, and you have configured it. Okay, so in this cases, what happens is, okay, this firewall avoids, let's say, if there is a very sensitive data which is there, some banking data which is there inside this machines. In those cases, we can set up this particular setup, but it's very rare. Okay, so what happens is gateway load balancer sits, or I can say it in easy words, traffic is directed to the gateway load balancer first, and then it balances the traffic across a group of registered group of registered virtual appliances. Okay, so Now you got it right. So in such cases, we can go for the gateway load balancer. It just only the difference which will come up is there is a external appliance or a external firewall which is there. Okay. So but when I say like when I use the word virtual appliance, it means something which are performing some security functions. Okay, or some packet processing. So something I need to do some processing of my packet or the request which is coming up. I can do by adding up something in between, some packet provider in between. So that is can be easily configured with the help of the gateway load balancers. You got it right? Please confirm. Just take a note of it. Please take a note of it, guys. Okay. I hope you got it. Yes or no? Perfect. Let's have a break. Uh, Guys, let's do one thing. Can we continue in the next class? I was having a little. Is it possible? Like I will take an extra class. We can do it. Is it fine? I'm really sorry, but yes, I have. So, like my daughter missed the school bus. Now she is just waiting. Okay, I'm really sorry. Yes, yes. Okay. Thank you. I'm really sorry for that, guys. Yeah. Really. She's just waiting for from 20 minutes, and I was like, yeah. I'm sorry, sorry. Okay, that's the reason I didn't take a break also because I knew that like I might have to leave little early. I'm really sorry. Okay. So I just have to drop her to the school. It will take around 20-25 minutes, so I cannot take that break also. Okay. Thank you. Thank you, guys. We will start with the practicals tomorrow. We will do the complete practicals and thank you. For this gateway load balancer, I will try to share you some videos and some notes. Okay, I will see if there is workaround without some basic free firewall we can use in between. I will try to configure and check it out once. In the companies, we already get it configured, so we don't have to really worry about it, but I will check if there is some workaround. Okay, thank you.